Hi, kids. Hey, look. Check this out. I love seeing this. For those of you that are a little nervous, you may not want to see this, but it's finals week. I'm doing some evening review classes at my school. For those of you that are subscribing, you can just pretend and do these at nighttime and pretend like you're at my evening review session. But you can't ask questions. And for my students that are too lazy to come into my evening review sessions, I'm glad to see you're here working on these problems. The document can be downloaded. It's at Mr. Krause, Krause. I know that's in cursive though, so it's hard to read. Math.com, so MrKrausemath.com. Go to Regents Review and scroll down to the bottom. You'll go by all the Regents exams and those quizzes I just never got to. And then in the bottom, there's got to be 5 or 6 evening review sessions and their videos, or after school review sessions. And then this week I'm going to put 3 more videos up. Today we're going to talk about logs, difficult equations, and factoring, I think. I don't remember this factoring too much. I'm not sure how much of this I put in. Oh yeah, I think I got some in there. And some binomial probability. But I don't remember, did I put binomial probability in this? Oh yeah. Oh, this is going to take forever. Listen, watch what you need to watch. Fast forward, rewind, try the problems out, see if you got the right answers. Hopefully this helps out. Hopefully I'm doing it the way your teacher did it. If not, they should be doing it this way. And hopefully this helps out. Listen, if you are using my videos and you like what you see, you can hit the subscribe button. If you've already hit the subscribe button, hit the like button. Don't hit the dislike button. It hurts my feelings. Don't dislike my videos. These things take forever to make. Good luck on that region. Study hard. If you haven't gotten my flashcards yet, get my flashcards. There's also a video on that same website. All right, guys, you ready to rock and roll? Here we go. So some of you look at this and you say, oh my God, effing fractions. And then some of you go, oh, that's not too bad. I can handle that. First things I don't like about fractions are these minus signs right here. So I'm going to change this to a plus and make this a minus. Just makes my life a little more comfortable. The next thing I'm going to do is I'm going to make this a little bit bigger, by the way. I'm going to see if I can get this thing a little bit bigger. Let's go 150. Nah, that's completely useless. Let's go 200%. Ah, there we go. So what I want to do is I want to look at these denominators and see, okay, I have an x. This is not an x and a minus 1. It is an x minus 1. That is one thing all by itself. So my common denominator, or my lowest common denominator, is x minus 1. And you're going to see me do this over and over again. I'm going to multiply through by that lowest common denominator. So I'm going to multiply this one by x and x minus 1, this one by x and x minus 1. I know there's teachers out there that find the common denominator and delete the denominator. I'm just not that kind of a person. I like multiplying both sides by the same thing. So we're going to multiply this one by x and x minus 1. Then I'll come through and I say, okay, this x cancels with this x, and it leaves me 1 times x minus 1, or just x minus 1, plus this x minus 1 cancels with this x minus 1, leaves me, negative 2x. Perhaps I should not have put that plus in there so quickly. Leaves me negative, this is negative 2x, is equal to, and this x cancels with this x, leaves me, and I got to distribute this 2x minus 1. Beautiful. Beautiful. So on the left side I have negative x minus 1 is equal to 2x minus 1. Ooh, things are running slow. As usual. I'm going to add this 3x and bring it, or add this 1x and bring it over. That makes 3x. I'm going to add this 1 and bring it over. That gives me 0. Divide by 3 and I get x equals 0. I hate that because that's really irritating. So what I'm going to do is I'm going to check my answer. So I'm going to go to my calculator and I'm going to take 0 and store it into x. By the way, if you have an 84, you can also do this on your 84. It's not a problem. The stow button's down here on the right, on the left somewhere. Store that in there, and then I don't remember what the equation was. It was control division 1 over x minus, minus 2, daggone it, control division. Let's see. Turn it back on. 2. That was my son. He just turned the lights out on me. Ah, there we go. X minus 1. And I'll hit enter. And I have no idea what I got, but then I'm going to do control division. I'll look in a second. 2 over x. Hit enter. If those two things match. Wait a second. It's undefined. 0 can't be one of my answers. All right, kids. What did I do wrong? Because 0, notice, makes it undefined. Told you there was a reason I was feeling uncomfortable about this. So, clearly that's not an answer. So clearly I need some coffee. Brugers, help me out, baby. Now, I either made a mistake. See, that's disconcerting because now I don't like, did I make a mistake? Do they never equal each other? Lost my pen pointer. Here's my pen pointer. Hold on a second. So what I need to do is I need to go back and take a look. See if I made a mistake. I did. It's such a common mistake. I even told you I was going to do what I was going to do, and I didn't do it. It's really embarrassing. 2 times -1 is -2. So there's some, by the way, I did not do this on purpose. This was a complete and total screw up. So those of you feeling a little less confident about going on with some more problems with me, please don't. I don't do this too often. Now the rest of my students are going, oh yeah, every once in a while he's kind of brain dead. So I'm going to bring that -x over, and it gives me 3x, and then I'm going to add 2. I'm going to add 2, and I get 1. Divide by 3, divide by 3, and I get x equals 1/3. And I am 99% sure that that is the right answer. So I'll do 1 divided by 3, control var x, throwing that in. I'll type in left side, and then I'll type in the right side, and you'll see that they both turn out to be 6. Yay! Sorry about that, kids. Woo! You know what? I just learned a lesson. I learned the lesson that if you don't drink enough Brugger's coffee before you start your first problem of the day, things don't go your way. And I'm a poet. And I didn't even know it. Okay. Guarantee the next problem I don't screw up too badly. All right, let's take a look at this one. The common denominator, lowest common denominator is... Anybody see my mouse pointer? Oh, yeah, here we go. This is when I get a little frustrated. Because I can't find my pointer. All right, there it is. All right, so my lowest common denominator in this case, is 2x. So I'm going to multiply everything through by 2x. 2x, 2x, and 2x. On this one, the 2's cancel, and it leaves me just an x. Equals. Ooh, the good thing is this 2x and this 2x cancels, but I am going to distribute that negative, and I'm going to try to do it correctly. -x plus 8. How many on that last problem saw my mistake and go, my God, this guy is an idiot. And he's bald. That was rude about the bald butt stuff. I really take offense to that. Actually, I don't care. And we'll multiply these, we'll get 2. We're going to bring this x over by adding it to both sides. So I get 2x is equal to 10, or x is equal to 5. I am not going to check every these. I'm hoping they all work. You'd think I would have worked these out ahead of time. Listen, man, there's only enough time in the day. So we're going to fly through these. We're going to do them quickly. Common denominator here, if you look at it, 4, 6, and 12. The smallest number that all three of those go into is 12. And there's an x. So my lowest common denominator is 12x. So I'm going to put a 12x next to each and every one of these. Going to come through. This 4 goes into 12 3 times, and the x cancels. So, wait a second, got to be careful. Let's see if I can not screw this up. 3 times 3 is 9 minus 3x squared. That squared right there tells you you're going to factor. Plus 6 goes into 12 twice, so I've got 10x. This 12x cancels this 12x equals 1. Because this is negative, everything's going to the right side. So 0 will be left on the left side. I'm going to bring this negative 3x squared over. I'm going to make it positive 3x squared. I'm bringing this negative 10 over, or this positive 10 over. It's going to be negative 10x. And then I have to subtract 9. I already writing down what I think the answer is going to be. Subtract 9, and I get negative 8. Oh my God, I got a factor. I hate to factor. I already had fractions, and now I got a factor. Drink some Brugger's coffees, kids, and the factoring will go much easier. Although you can't do that on a Regents exam, because I don't think they'll let you bring Brugger's coffee in the Regents exam. By the time you get there, it'll be cold anyway. But it could help. Maybe that's what I'll do. I'll pass out Brugger's coffee during the test. I won't. Let's see. We'll go minus 4 here, and how about a plus 2 here? Does that work? These give me negative 12. These give me positive 2. That's correct. That means my answer here is x equals negative 2 over 3, and x equals 4. I'm going to check this one, but I think it's going to be the last one I check. And I want you all to know something. Check everything. Even the 84 has a stove feature on it. Check everything. Don't be lazy. The world has enough lazy people in it. I'm trying to shrink this. Oh, yeah, that was fun. Hit the wrong thing. All right, so let's figure it out. We got negative 2/3. So negative 2 divided by 3, stow x. You guys with the 84s, you do the same thing. You type in it in, and you hit the stow button down here, and then the x button's up here somewhere. All right, so I'm going to type in this left side correctly, hopefully. So it is control division. 3 minus x squared over 4x. The only value that would not work, and when I do get one like this, I'm going to show it to you. The only value that would not work would be 0, because you're not allowed to have a 0 in the denominator, because 4 times 0 would be 0. I believe this is just 5 over 6. And I'll hit enter. I get negative 1/8. And on the right side, I put in 1, control division 1 over 12x. Woo! Negative 1/8. And my other answer was 4. So I'll take 4 and I'll stow it into x. Check everything. I'm not going to today only because, well, you don't want to be here all day. If your answer matches mine, we're in pretty good shape. If your answer doesn't match mine, well, check your answer. And if I'm wrong, send me a quick email. Maybe I'll send you a gift. See, 148th. A gift of more math problems. Oh, yeah. I know you're thinking, that's the best gift anybody's ever given me. Mr. Krause is always thinking about us. Oh, my gosh. This freaking thing. All right, look. Oh, this is an easy one. Let's do this. So my common denominator here, if I put these in parentheses, because they're like married couple, is 2x minus 1. So I'm going to multiply this by 2x minus 1. I'm going to multiply this by 2x minus 1. And I'm going to multiply this by 2x minus 1. Cancel, 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 cancel. So, nothing to distribute here. I just get 3x squared. Oh no! Factoring! You son of a... Just kidding, Mr. Krause. We love you. No, you don't. But I hope you like the videos. Okay, here we're going to have to distribute this negative 2. Let's see if I can do this carefully. So that's negative 4x. And then negative 2 times negative 1 is positive 4. All right, all of this stuff's coming over here because I want my x squared to be positive. Never want your x squared to be not positive. I'm going to add that 4x and bring it over. And I'm going to subtract that 4 and give me a negative 8. This looks like very similar factoring. Nah, not really. I think it was just the 3x. So I'm going to put 3x here and x here. how am I going to do that? They got to add up to, let's see, 4 and 2, 6. Oh, that ain't going to work. Put a 2 here. Nope, put a 3 here. I put a 3. I put a 4. 4 and a 2. That's not going to work. Is this not factorable? Did I screw up again? Negative 4x. Oh my God! Seriously? I'm going to have my head examined. Seriously, this is ridiculous. Unbelievable. Embarrassing. Not going to lie. Plus 2. When I add 2 and come over. Oh, Brugers, you're letting me down, brother. I get minus 6. That's a much better answer. Much better. Let's go with plus 3 and minus 2. Because this gives me 9 minus 2, which is 7. X equals 2/3 and x equals negative 3. I have to tell you, students, and I'm not going to lie, I got like 1 foot and another foot on the way already in the summer. And I know you do too. And I think that's why my brain's getting a little muddled here, because I've been doing math so much this year, I feel like I've done nothing but math. You gotta keep that away. You gotta keep plugging along. You only got 5-6 days left before this Regents. If you're watching this video the night before, you got, well, hopefully you're not, because you probably waited too long. But anyway, you don't have much time, right? It's right around the corner. So stay with it. Common denominator here should be obvious, is 4x. If you don't understand it, pause it for a second, take a look. Lowest number is 4, and I got a positive. Oh, don't like this plus. I'm going to make this a plus and make that a minus. It causes problems later on. All right, let's see what we got. 2 goes into 4 twice. That leaves me 2x, because it's 2x here times 1 equals, goodbye, x squared minus 7x plus 10. That 2 goes into 4 twice. That x cancels with that x. And let's see if I can write this down correctly. Minus 2. Amazing. Wow, I actually got it right. So I'm going to bring this 2x over by subtracting it to the other side. So I get minus 9x plus 8. Oh my goodness, kids, you got to be smiling today. The factoring can't get much easier than that. By the way, if you're just watching the performing monkey, I'm going to get a performing monkey, I think, and put in this video somewhere. Minus 8, right? Because performing monkeys, guys, I just spilled a little bit of coffee. Got to say something. Sorry, coffee. All right. Now, I'm not your performing monkey, okay? If you're just sitting here watching me do this problems, what are you going to do on the day of the Regents? You'll be like, oh, where's Mr. Krause? I need my performing monkey. No, you have to do these on your own. Pause the video. Try it on your own. Check the problem out. If you don't know how to start it, then come. Take a look. How did Mr. Krause start this? I hate talking about myself in the third person. It's really sort of annoying. Mr. Krause hates that. Mr. Krause really hates when his pen goes away. X equals 1 and x equals 8. Don't you know those people that are like, oh, Betty doesn't like when people do that. Oh, Betty's a little weird. Betty ought to stop talking about Betty in the third person. Do your problems yourself. Come here, check them out. Is my collar up? It's like June. It's still cold out. Isn't that ridiculous? For those of you in the nice warm areas, we're not. It's New York. Nothing's warm in New York. X minus 3 is my common denominator. That was an easy one. So let me bring out the red pen. I know you all hate to see the red pen. Gone. 4x. The good news is there's no squares in this problem, so we're really not going to have to factor. Oh my goodness, Mr. Krause. Let's see if you can distribute this time. This would be 2x. And this would be minus 6. X minus 3's cancel here, and I'm left with a positive 12. All right, bring this 2x over. I get 2x equals 6, or x equals 3. Woo! That was an easy one. Mr. Krause loves when the problems are easy. Dun, dun, dun. Sorry, kids. This question is actually off of an old Regents exam. So if you've done all the old Regents exam, you've actually done this problem. I'm pretty certain it was a part 4 question, 6-point question, because it is very, very difficult. It's one of those questions, if you saw what you had to do originally, it's not too bad. But if you didn't, it's a problem. I'm going to do this one slightly different because it is so difficult. And for those of you that don't see it, it's because of this right here. Do you see that that's backwards? If you guys take and you're doing problems like this and you're very discerning, which means you're really thinking about things, when you see a binomial that's backwards, the first thing that should come to your mind is -1 rule. Now, I call it the -1 rule. It's really not a rule, but it's the -1 rule. Something's wrong with that. Don't like it, can't stand it. It's kind of like that kid in class that doesn't do homework. Yeah, you know who I'm talking about. Yeah, there's like 4 of you. You're driving me crazy. But it's backwards. And it really ought to make you think, why is that backwards? Oh, that's the thing they're trying to F with me on. A fraction. For those of you parents listening, I just meant fraction, or factoring, or fun. Anyway, that's the thing, that's the problem. So what we're going to do is we're going to eliminate that problem right now. And I'm going to eliminate it by introducing what I like to call the -1 rule. So this is x plus 3. I like that. Not a problem. Minus. I'm going to take care of that minus in about a second. 2. I don't like this. It's backwards. So I'm going to use the -1 rule to turn it around. Well, in order to do that, you have to introduce a negative. Well, those two negatives, which are nice, make a positive. But in order to turn that thing around, you have to introduce a negative into the problem. The reason being is because 3 minus x, if I take a -1 out, this is really -3 plus x, right? Because if I distribute it, I get positive 3 minus x. Well, this is the same as -1 times x minus 3. So it allows me to turn it around by introducing a -1. So anytime you see a binomial backwards, I want you to think, that's right, it's the -1 rule. And just turn it around and put a -1 in the problem. Later on, you'll see me when we do the complex fractions, if you do that one, or the more convoluted fraction problems, you'll see me just cancel them and then throw a -1 in the numerator somewhere. Okay, let's finish this problem then. Because now the problem's not too bad. Now that I've seen that, I recognize it, now the problem's not too bad. This is going to be x plus 3 and x minus 3. All right. Common denominator, this should be obvious, is x plus 3 and x minus 3. Because those are the only things that are in the denominators. X plus 3 and x minus 3. It was kind of an unfair, it's a fair question to ask, but it's kind of an unfair 6-point question, because if you don't see that, this problem is a nightmare, and you're probably not going to get very many points, which is why it's kind of an unfair but fair question. So the x minus 3's go, and I'm left with x minus 3 times 1. This x minus 3 goes with this, and I got to distribute this, hopefully correctly. So plus 2x plus 6 equals 4, because that cancels with that. On the right side, on the left side, I'm going to get 3x plus 3 equals 4, and I get 3x equals 1, or x equals 1/3. And because it's the last problem, I think this is the last one of these, I'm going to check it. So I'm going to stow 1/3 into x. 1 divided by 3, control var x. And then I'm going to type it in. Control division 1 over x plus 3 minus control division 2 over 3 minus x. I'm pretty sure that was the problem. Enter. Ooh, -9 over 20. What is that? And then 4 over x squared minus 9. Control division 4 over x squared minus 9. Enter. Yay! It worked. That's it. All right, kids. Why do you hate me, Mr. Computer? Oh yeah, see, hates me. Oh, and now I lost my blown up bis. Oh, stupid machine. By the way, still looking for that same machine. Okay. All right, kids, this problem's not too bad, but I want to highlight one thing for you. I'm going to highlight this thing right here, and I want you to read to me what this says. Just read it. Read it. Ready? Solve the equation below algebraically and express your answer in... Did you read? You can't factor this? Don't even try? Did you read? Ooh, gonna have a radical that I have to simplify? Yeah, you're going to. Now, this problem's done very similarly to the last couple of problems, but we're going to have to do a little bit more work. We're also going to not be able to solve this by simply factoring it because this signifies, the other words that signify that you're not going to be able to factor it is rounded to the nearest blah, 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 blah. Okay, so let's get started. Make them fractions. 10 over 1, x over 1. The lowest common denominator between the x, the 1, and the 1 is x. So I'm going to multiply everything through by x. Boom, boom, boom. Over here, the x's cancel. That's beautiful. And I get 13 equals 10x minus x squared. Well, everything has to go to the left side because I don't want to have a negative x squared. So I end up getting x squared minus 10x plus 13 is equal to 0. All right. So there are two ways to do this one. I'm going to do both. So if you want to stick around for both, that'd be great. I'm going to do this using the quadratic formula, and then I'm going to do it using completing the square. And I'm going to do that a few times today so that you get comfortable seeing both methods. So first thing first is the quadratic formula. A is equal to 1. B is equal to negative 10. C is equal to 13. And D, which really just stands for the discriminant, but I like to do the work over here. Instead of having to try to do it in the problem, it causes all kinds of problems. The discriminant, which is b squared minus 4ac. I'm going to do the work right here. Now, do you see that this b is negative 10? Please, 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 please don't write negative 10 squared here. It's really annoying. You know what, even if you do it inside the radical in the problem, you know what negative 10 squared is. It is always positive. Just write 100. If you try to do it in your calculator, it's going to give you a negative answer, and it's going to be totally wrong. So minus 4 times 1 times 13. Well, if you do this one, you get 48. All right, so that's the radical I'm going to end up simplifying. You don't see the radical yet, but it is. So x equals negative b over 2a plus or minus the square root of the discriminant. I'll write it in here, minus b squared minus 4ac all over 2a. All right, so x equals, now this is b, so negative b is positive 10 over 2 times 1 plus or minus the square root of 48 all over 2 times 1. Okay, so this turns into 10 over 2 plus or minus. Now the square root of 48 I got to bring off to here to the side and work on square root of 48. Now hopefully by now you've done this a billion times and you know we love to ask 48 because it's that weird one where it's 16 times 3 or 4 radical 3. So I'll put that back in the problem. 4 radical 3 all over 2. So my answer is x equals 5. That's 5. Plus or minus 2 radical 3. Because this 2 goes in there twice. So there's the answer. There it is right there in all of its glory. Now the cool thing is, all right, it's not really cool, but it's nice to know. I can check this. I'm going to store this. So 5 plus 2 radical 3 stow x, and then I'm going to type this puppy in my calculator. Let's see, it was control division 13 over x and 10 minus x. Catching. Wait a second, there were two answers, weren't there? Enter. I'm going to retype all that. Just change this to a minus, because remember, it's plus or minus, so I'll change this to a minus. Make sure you're not using the negative button as a minus. It really is just a minus. Hit enter. And hit enter. There's that one. And then do 10 minus x. Hit enter. Oh, look at that. Yay, I got it right. So that's a cool thing. So I did it one way. Now I'm going to do it the other way. So I'm going to go back to... Don't you wish your pen erased as well as that? That's why everything's going to go digital eventually. All right, so I'm going to go back to this quadratic, and I'm going to do this by completing the square. Completing the square says you have to have a 1 here. I have a 1 there. This middle term should be even. If you're trying to do completing the square where that's not even, dummy, and move the 13 over. So I get x squared minus 10x. Now, what I call it completing the square, and since it's called completing the square, I put a square here, equals negative 13 plus that same exact square. Well, what goes in the square? X. Down here, I'm going to cut this in half and put there. But we're squaring it, so here goes 25. Now, if you haven't done completing the square, this may look really weird to you. If you have, this should be obvious. Half of it goes here, square it to go there. But if you put a plus 25 here, you got to put a plus 25 here. So now I'm left with x minus 5 squared equals 12. We're almost done. You take the square root of both sides, but when you take the square root, you put a plus or minus. So I get x minus 5 equals... Now, plus, I'm going to simplify the square root of 12 up here. I know that to be, it's a little bit easier simplifying, square root of 4 times the square root of 3, and this is just a 2. So, plus or minus 2 radical 3. Now, I'm almost done. I just got to bring the 5 over by adding it over, so I get x equals 5 plus or minus 2 radical 3. And that, my friends, is completing the square. I'll do that a couple times. I think I've got a few problems I can do completing the square on. Ooh, look, it's going to cooperate. All right, whenever you see four terms, lots of terms here, what you're going to think about is grouping. We want to group these things. We want to make them look similar. Minus 9x minus 36. Can't factor and do all that crazy stuff until you have it equal to 0. We're going to look at the first two. I can take out an x squared. And I'm left with x plus 4. Now, if this is going to work out properly, which it should, then I also should have an x plus 4 here. Well, 9 goes into 36 4 times. That's nice. Really, what you're taking out is a negative 9. And negative 9 times x is negative 9x. And negative 9 times 4 is negative 36. So that worked out beautifully. Now, if I look at each of these groups, this group, and I look at this group, they each have an x plus 4 in common. So I'm going to factor out the x plus 4 out of each of those groups. Gone. And I'm left with x squared minus 9. Well, I'm not quite done factoring because I have the difference of perfect squares there. So this is x plus 4, and this is x plus 3, and x minus 3. I'm still not done because I got this equal to 0 things, which means you have to solve it, which means you have to give me answers, which means if you don't, you're going to get it wrong. So my three answers are x equals negative 4, x equals negative 3, and x equals positive 3. That one's done. Uh-oh, simplest radical form, aka not going to be able to factor it. All right, so bring everything to one side. Let me get a new color because I'm not really a big fan of black. So I get 6x squared minus 2x minus 3 equals 0. Now, remember when I said the middle term has to be equal to, it has to be even in order to use completing the square? That's true. But I also said this has to be a 1. And if it's not, you have to divide through by 6. And that would give me negative 1/3 there. Not friendly. It's not going to work. So you're going to have to do this by the quadratic formula. You do not have a choice. So a equals 6, B equals -2, C equals -3. And D is equal to B squared minus 4AC. B squared is 4. It is not -2 squared. Drink coffee. Minus 4 times 6 times -3. Let's see. 24 times -3, negative 72. I'm going to guess this is 76, which we're going to end up simplifying. So, x equals -b over 2a plus or minus the square root of 76 all over 2 times 6. So, let me switch colors so you can see. I'll go a little festive. X equals 2 over 12 plus or minus. Let's talk about the square root of 76. That's the square root of 4 times the square root of 19. You may not have known that, but it is. So this is 2 square roots of 19 over 12. So my final answer is 1/6 plus or minus the square root of 19 over 6. All right. Yeah, I don't really think that's the right answer. Can't be right. I mean, who gives ridiculous answers like that? Can I check it? Of course you can check it. What was it? 1/6 plus or... So 1 divided by 6 plus radical 19 divided by 6 control var x. Now I did it that way, but it's going to make it look nice for me. See how it looks just like I have it written on my paper? I like that. So I don't remember what's going on. So I'm going to type in the left side, go back 6x squared and then 2x plus 3. So 6x squared, enter. Was it 2x plus 3? I hope so. Yay! Oh my god, that's right. That's a crazy answer. But I should check both just in case. Ding, 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 ding. Minus. Minus, not negative. All right, now check 6x squared. And then check 2x plus 3. Yay! That ridiculously stupid answer was the right answer. Yay! I'm so excited. And now, of course, I cannot. All right, gotta do this, gotta blow it back up to 200% so you can see the problem. My goodness, this problem doesn't like me. Okay, I got 4 items, right? I got 4 items, so I'm gonna end up grouping. Before I group them, I gotta get them to the same side. So I get x cubed minus 2x squared minus 16x plus 32 equals 0. Are you guys still just watching me do these problems? Because if so, yeah, I got a little message for you. You're a loser. No, I'm just kidding. I like you guys. I really do. Get to work. Do it on your own. Try them on your own. There's not going to be any performing monkey on the day of the Regents exam. You have to do this on your own. GCF is x squared. I'm left with x minus 2. If this is going to work, I need an x minus 2 here. Oh yeah, 16 goes into 32. I'm really taking out negative 16. What do they have in common? They both have an x plus minus 2 in common. So I'm going to factor that out, x minus 2. And then what I'm left with, and I'm going to speed things up here a little bit, is x squared minus 16. And I could put that in parentheses like I did above, in the above problem, the one I did up here. Remember this one? I left it as x squared minus 9. But then I had to factor it again, which took time. And I recognize it now. And I'm like, oh, it's x squared minus 16. So I'm just going to factor it to x plus 4 and x minus 4. Don't forget to write equals 0. And that gives me my 3 answers. X equals 2, x equals negative 4, and x equals positive 4. Should you check your answers? Oh yeah, check everything. Remember what I told you, kids. After 2 hours, now that's going to be at 10 o'clock in our school. Hopefully it's about the same time in your school. After 2 hours, take your pen, put it down. Sit back in your chair. Now, don't let your instructors think you're cheating. And I want you to take a break. And I want you to watch as people leave. Now, you know these people. You know who they are, right? They're the ones not doing their homework. They're the ones asking you for your homework all year long because they're too lazy to do it on their own. They're like, oh, I could just get it from that smart kid because he'll be nice to me. Just watch. Just look around. They're leaving. They're all leaving after 2 hours. Don't you dare. You put your pen down, you watch them leave. Because all the kids that are not going to pass this test are leaving. They've given up. It's Friday. It's 10 o'clock. They can go home and sleep. Sleep. Yay. Or go to the beach and hang out with their friends. Or not pass the test. You're going to pass the test. Not only are you going to pass the test, you're going to kick the out of this test. So stick around. Stick around. 2 hours and 30 minutes. 2 hours and 40 minutes. 3 hours. My kids are all staying the whole time. I love them. They're going to work for me. It's only an hour. It's like 1/1000th of your summer. Okay, it's not quite 1/1000th, but I think I worked it out. It's like one. I'm doing it right now. We're doing it. We're doing it. I know that's what you're saying. You're like, man, I wish you'd work that out. I'm going to do it. What do you got? About 75 days of summer? 75 times 24. It's 1/1800th of your summer. I think you can give up 1/1800th of your summer just to do a problem. All right, let's go to 10 because I don't know where I'm going. Go 10. All right, we got 4 things. We're going to end up grouping 25x cubed minus 25x squared minus x plus 1. Ooh, this is going to be a funky one. Funky Cool Medina. It's an old song. All right, so the common grouping take out of this is 25x squared. And I'm left with x minus 1. Well, if this is going to work, I need an x minus 1 here. Well, there's really nothing to take out of these things except a negative 1. Right? Because negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. Ah, wait a second. They now have an x minus 1 in common. I can take that out. And that leaves me 25x squared minus 1. Well, that also is the difference of perfect squares. 5x times 5x gives me 25x squared. And 1 times 1 gives me 1. So 1's plus, 1's minus. All right, 3 answers. X equals 1, x equals 1/5, and x equals negative 1/5. Yay! Are we almost done? I'm tired of factoring. Like, ooh. Read with me, kids. What does this say? 1, you're not going to be able to factor it. 2, it's going to be imaginary. You're going to have a negative discriminant. Now, if you do a problem that says in simplest a plus bi form, and you don't have a negative discriminant, start over. Yeah, screwed something up. All right, common denominator is x. We're going to multiply everything through by x. Remember, these are over 1. So I end up with, it looks very similar to the other problem, except this time we're going to end up with something imaginary. So this is 17 is equal to, although this seems kind of weird that this would turn out imaginary, x squared minus, oh yeah, it's okay, minus, or 8x minus x squared. Now, everything's going to the left side because this is negative. We don't like that. We don't like when it's negative. Oh, I can do this 2 ways. So I'm going to do this one 2 ways because I promised. I know you're like, Mr. Krause, you promised us you were going to do completing the square and the quadratic formula a couple of times. All right, stop bugging me. We're going to do it. Let's do quadratic formula first. Although I like completing the square because it's much faster, you can always do the quadratic formula. You have to decide. The reason I can do completing a square, by the way, is because this is a 1 and this is even. So it would work, but we're going to do that in a minute. Let's try not to mess this up. All right, A is 1, B is negative 8, C is 17, and D is B squared minus 4AC. B squared is not negative 8 squared. It's 64. Now, I've said that like 4 times. I hope you've heard me. Minus 4 times A times 1 times 17. Holy mackerel. Not sure what that is, so let's do that. 64 minus 4 times 17. I'm not multiplying by 1 because that would be kind of boring. Oh, negative 4. Oh, this is going to work out so beautifully. Equals negative 4. By the way, I didn't know that was negative 4. Okay, let's write down that quadratic formula. Makes my grader look like I'm a professional student, not some slack-off loser jerk. Doesn't know what's going on in the world. They're like, man, this kid knows the quadratic formula. He's going places. He's like going to be famous. Everybody that knows the quadratic formula is famous. All right, so negative b is positive 8. See, it's negative here, it's positive there. Over 2 times 1 plus or minus the square root of negative 4 over 2 times 1. Well, I hope by now in your realm that you know, let's go, this is 8 over 2 plus or minus square root of negative 4, 2i. Square root of 4 is 2. The square root of a negative is I. It's really a negative 1. So my final answer is 4 plus or minus I. Oh, you want me to check it? Oh, you don't think I can check it? Oh, I think you can. 4 plus I. Control var x. Catching! Oh, that's not checking it. So, control division 17 over x. Enter. I don't know. That seems kind of funky. I don't know what's going on here. What's the other one? What's the other side? 8 minus x? 8 minus x. Ooh. Now let's check the other one. Ding, 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 ding. Bing. Ding, 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 ding. Minus, not a negative. Enter. All right, then we'll do bum, 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 bum. Enter. Enter. Oh, 4 plus I. Enter. Enter. Oh, I hit the wrong one. Sorry. Didn't go up high enough. 4 plus I. Yay, it checks. Let's do completing the square because it's so much easier. If you know it. Now, you don't have to, if you don't like completing a square, it's like completing a square is like completing the no way in heck. Then don't do it. Skip. Fast forward. Get by this. If you want to watch me, watch me. If you're stalking me, that's a little creepy. Not going to lie. First step, this has to be a 1. Second step, this has to be even. Third step, get the constant to the other side. So I'm going to rewrite it. X squared minus 8x plus completing the square equals negative 17 plus completing the square. In the parentheses goes half of this squared. Half. In this goes this thing squared. 16. 16. So negative 17 plus 16 is negative 1. Okay. Take the square root of both sides. Square root. When you take the square root, you put a plus or minus. Otherwise, you're going to get minuses on your test. Ooh, that was good. I got to market that one. All right, so we end up with x minus 4 equals plus or minus. What is the square root of negative 1? Lo and behold, it's an I. So, bring the 4 over. I get x equals plus 4 plus or minus an I. Mr. Krause, math is so much. What the There's fractions on top of fractions with factoring. What the fraction is that? Factoring, fractions, fractions on top of fractions, and factoring? You gotta be... Oh, Mr. Krause said these are easy. Mr. Krause likes to talk about Mr. Krause in the third person. Mr. Krause, a little psycho. Not gonna lie, if you were in my class, you'd be thinking so too. Who drinks... Ooh, just hit the microphone. Sorry, microphone. Who wakes up at 4:30 in the morning? By the way, it's late today. It's like 7:15 right now. But who wakes up at 4:15 in the morning to do math? Oh, this guy. You're doing this divided by this. So it looks like it's fractions on top of fractions, but it's really the same as this. So what we're going to do is we're going to don't forget, you have to turn this into a multiplication problem by flipping this one. But the first thing I want to do is write it like that, so I remember, oh yeah, it's just really that's all that means. And then I'm going to factor it. Now, the next thing that I'm going to look at is this thing right here. Beep, beep, beep. -1 rule. Beep, beep, beep. -1 rule. Anytime you see a binomial backwards, you're going to end up doing the -1 rule. Now, we're going to factor this. Now, because the 4 comes first in my parentheses, I'm going to put my 2's first, because 2 times 2 is 4, plus x and minus x. That's this one, done. I'm going to factor this one. That factoring's a joke. X plus 3, x plus 4. Done. Now I'm going to factor this one, but it's coming to the bottom, and it's got a GCF. It's 2x minus 2. And there's nothing to do with that x plus 3, but bring it to the top. All right. Problem not too bad. Now I'm going to take care of my -1 rule right now if I can find my marker. I'm going to have to end up saving after this and going back to work. So, by the way, on your test, have a black and a blue pen so you can get rid of stuff nicely. All right, so I'm going to take care of my -1 rule. This here is backwards from this one. Because that, they can cancel, but they make a -1. That's -1 times. Don't know what happened to my pen. Lost my pen again. All right, so those cancel, and when I get my pen back, all right, I think I might have my pen back. Nope, don't have my pen back. All right, I'm just going to cancel this one, finish with my mouse, if I can find. All right, so this x plus 3 cancels with this x plus 3. And I think that's actually it. So let's see if I can get my mouse back so I can start, or my pen back so I can start writing. Oh yeah, I think I got it back. So the only thing I have left over is this. Don't forget the negative. This and this. Now wherever they are, they stay. So in this case, I've got a -2 plus x all over 2 times x plus 4. Do you have to distribute the negative? No, and please don't. Why? That is the most simplified answer. There's no reason to distribute that negative. All it's going to do is maybe be an opportunity for you to make another mistake. All right, I'm going to pause this. I'm going to save it so I can get a fresh graph. We've already been going an hour. Oh my goodness, kids. It's ridiculous. All right, guys, I'll be back. Well, just took a little break, kids. I don't know if you noticed. You probably didn't. I don't really care if you did or didn't. Of course, my thing's going to back up again. So anyway, I just had to get a fresh cup of coffee. Burgers! By the way, still have yet to receive a dime from Brugger's. So, and I'm still using this old, crappy computer. So, if your parents are independently wealthy and would like to send me a brand new, state-of-the-art computer so I can continue to do my videos, I'm just kidding. Let's get started. Do you see it? Do you see it? I know you see it. I know it's screaming at you. It says, highlight me, highlight me, highlight me. Now do you see it? -1 rule. Yes, sir. It's coming. It's the -1 rule. So we're going to end up turning these all into multiplication. And I'm going to take care of this one right now because this one gets flipped. And I don't want to forget to flip it. So I'm going to do this one first. This x squared plus, what did I just write down? Oh my goodness. Let's try that again. X minus 4x plus 2. Those multiply to -8, add up to positive. Oh my gosh. I just did that backwards. Ka-ching, ka-ching. All right, let's try this again. Maybe I need to drink some of my coffee. So it's x plus 4, x minus 2. They multiply to -8 and they add up to positive 2. In the numerator, I'm going to have 4 plus x and 4 minus x. So I've taken care of that one. Done. This one does not get flipped because it's in front of. So let's just take out a 2. X minus 2. And down here, I can take out an x cubed. That's really weird. X cubed, x minus 3. Over here, this is like, oh, this one always screws kids up. First thing you should look for anytime you're going to factor is a GCF, x minus 4. All right, now this has 4 terms. So I want to factor by grouping. I'm going to do it right up here. So I'm going to take out an x squared, and I'm left with x minus 3. Now, we've already done a problem similar to this, plus 6. And then don't forget, this has to match, x minus 3. Now, I took out the 6 because these have a 6 in common. I also knew I needed an x minus 3. All right, so x minus 3 goes here. And let's see, x squared plus 6, can't do anything with that, so I'm just going to write it down as x squared plus 6. Now, I said last time, please have a black and a blue pen. It's only 2 colors you can use. Have a black and a blue pen for your test. Also a highlighter for things like this that you want to recognize. Okay, let's start lopping crap off. Oh, take care of the -1 rule first. Where is it? Oh, it's right here. It's this x minus 4 and this 4 minus x. That is a -1 rule. It's only with minuses. It's not with pluses. Pluses are the same thing. And what you do is you say, okay, those two can cancel each other out, but they make a -1 rule. Now I'll look at these two. This is x plus 4, and this is 4 plus x, and 4 plus x and x plus 4. They're exactly the same. You can cancel those out. They have nothing to do with the -1 rule. Okay, x minus 2, x minus 2, x minus 3, x minus 3. Now, the beauty of being able to do this in multiple colors is you should be able to see what's left. All right, so what do I have? I have a negative. Start with that. I'm going to put that right out front. And then I have a 2x squared plus 6 all over this x, and this x cubed make x to the 4th. There's my answer. Now, if you don't like that negative out there, you could have -2x squared plus 6 all over x to the 4th. There it is. That's my answer. What's next? I'm having so much fun. Oh, this one. Oh, yeah. I forgot I put that one in here. Okay, so I'll tell you about that one in a second. So, all right, so I've already told you that we're going to take this one and we're going to divide it by this one. So these two, by the way, if you don't have the TI Inspire, these two probably aren't going to be a lot of fun. So on this one, and I'm going to need a little extra room on this one, I'm going to take out a 6, and I'm left with x squared minus 25. All right, I had to go discipline my doggy. Sorry, make sure I'm still recording. It's like the most convoluted, I'm all over the place, scatterbrain guy working. All right, we're good. All right, so I did that one. Now, ooh, this one right here. So let me factor this one. Ting, 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 ting. I don't think you'll ever see anything this hard on a Regents. I think it's going to be 3x and 3x. Is it 15 and 5? 15 would be 45 and 5 would be 15. Yeah, so it's going to be plus 15 and minus 5. So that gives me 45 minus 15, which is 30. Woo, that was a tough one. Don't forget, this one here is getting flipped, right? I'm thinking, nope, there's no GCF. So, yeah, this is another one where you probably want to use your calculator for. So I'll come over here, I'll go menu 3, 3, 3. Doesn't like me. Menu 3, 3, 1. It's a real one, and my numbers are 24, negative 49, and 15. So 24, negative 49, and 15. And I will hit enter. Hit enter. And 3/8 and 5/3. So 3/8 and 5/3. That means it's going to be 3x and 8x, and it's going to be 8/3, so it's -3 and plus, oops, not minus, plus, -5. And -5. Let's see, that's -24. That's 24x. This is -9 and -40 and +15. Perfect. All right. And then 60x, so I can take out a 12x. And this is backwards too. So this is going to be, let's see, 12 goes into 60. Five times. So that gives me 5 minus x. Not really happy about that. I don't know why. Oh, I forgot because I'm not finished with it yet. So don't forget, this is really x plus 5, x minus 5. By the way, if you did this one on your own and you did it beautifully, nice job. Let's see. This 3x minus 5 cancels with that 3x minus 5. Oh, I should take care of the -1 rule. It's right here. 5 minus x and x minus 5. Don't forget, we need a negative here. -1. This 6 goes into 12 twice. And I've got a little bit of a problem. I screwed something up. I didn't see that this, wherever it is, had a GCF. I forgot I was going to get a new pen thing. This thing had a GCF, because if you look at this right here, do you see this right here? This is really 3x plus 5 right here. I didn't take out the GCF to begin with. So now this x plus 5 is going to cancel with this x plus 5. So let's see what I got. I got a mess here, and I apologize for that. I got negative 8x minus 3 left in the numerator, and the denominator I have 6. All right, I'll try to do a better job on this next one. Oh yeah, this was me having fun with my math students earlier this year. And if you don't have an Inspire, you might want to just skip this problem, because this one's going to be a kind of a beast. So let's try this. So this one right here, I'm going to use my Inspire for. So menu 3, 3, 1. This time it is not a, it is a third degree polynomial. So I will choose 3 and click OK. Now I put these values in. 1, 7, -30. Let's go. 1, 7, -36. -252. Hit OK, hit enter. So my 3 answers here are -7, -6, and 6. So this thing factors to x plus 7, x minus 6, I need a new battery, I think. I either need a new battery or a new computer here, kids. So I'm going to pause this for a second, get a new battery. All right, hopefully this works. So far, so good. All right, so x minus 6 and then x plus 6. Again, if you don't have an Inspire, you may want to just skip this one. All right, so this one has a GCF, so you have to take that out first to even use the Inspire. So I can take out a 10x. So I'm going to take out a 10x. And I'm going to rewrite this one so it's in the right direction. So it gives me x squared minus 11x plus 30. And so I don't need my Inspire for that. That's 10x, x minus 5, x minus 6. That one was pretty easy. Times. Now this one, because I'm dividing by it, I'm going to flip it. So let's see, 12, 3 goes into that. Nope, 3 doesn't go there. So that's pretty much prime. So I'm going to, let's factor it. And I'm going to end up multiplying by this as well. So this one's going to get flipped. Don't forget to flip this one. So 12, 67, and 30. So menu 3, 3, 1. Yes. 12, 67, and negative 30. So it's negative 6 and 12 and 5. 5 twelfths. So because it's 5 twelfths, that makes it 12x minus 5 and x plus 6. Is that right? Positive 72 minus 5. Perfect. All right, so in this bottom one, that one has no GCF either. But because I have a 12x on top, I'm going to put a 12x here and a 3x. And let's see, 12x, I'm going to go minus 5. That's what I'm thinking. And then minus 7. Let's see, that's minus 84, minus 15 would be minus 99. Beautiful. So this one's got to be 5x. Oh, wait, there's a 5 as a GCF, so let me get rid of that. This one's got a GCF of 5. So I'll take this 5 out, and I'm left with x squared minus 6x plus 5. And that factoring is not too bad. 5, x minus 1, x minus 5. By the way, if you could do this one, you're a hero. And then we know it's going to be 3x. Oh, no, we're not doing that again. And x plus 7 and minus 7. There we go. We're done. All right, so let's start lopping crap off. This problem's kind of old. All right, so this x minus 5 cancels with this x minus 5. This x minus 6 cancels with this x minus 6. Do you see what I screwed up, kids? I said this one had to be flipped, and I didn't flip it. So this one really should be 12x minus 5, 3x minus 7. I knew something was messed up when I wasn't going to start canceling stuff out. 12x minus 5 and x plus 6. That's what this should be. This shouldn't be here. This should have been upside down. I should have just not done this problem. So this cancels with this. This is going to cancel with this. This is going to cancel with this. This 5 goes into 10 twice. Oh, this was an x plus 7. So this x plus 7 is going to cancel with this x plus 7. So it looks like I'm left with x minus 1 over 2x. Dumb problem. Sorry, kids. Shouldn't have put it on there. Just for fun. All right. Now we're going to solve logs. Do a little bit of log work. Down. All right. Whenever you solve a log, it's all about the base. So what we're going to do is turn it into an exponential. If you have a log, you solve it using exponential. If you have an exponential, you solve it using a log. And by the way, I'm just doing this because I like a change of pace. We've been doing a lot of factoring, so let's change the pace. It's all about the base. X to the... Now, what happens is these two flip. They switch. So x to the 5/3 is equal to 9x minus 4. Now, you can either type in x to the 5/3 in your calculator or just do it in your head. Either way, you'll end up with 32 is equal to 9x minus 4. Add the 4 over, I get 9x equals 36, x equals 4. Now, I know I've said check everything. Logs must be checked. You must check logs. So, I'll take 4 and stow it into x, hit enter, and then I'll do log base 8 of 9x minus 4 and hit enter. 5, 5. I got to figure out what 5 divided by 3 is. Oh, look, 5 divided by 3 is 6. All right, we're good. So that one worked. So this one here is a little bit different It's all about the base. It's still a logarithm, so we still have to solve it by using the base. So the base in this case is x plus 3. It's a little more difficult. We're going to square it because we're going to switch these two. So it's all about the base. Copy down the base. All about that base. About that base. Oh, yeah. My kids love when I sing in class because I'm like a singing fool. I'm a fool singing. Don't forget, this needs to be double distributed here, and I'm not going to really go through that math, but you have to. That's what squared means. So I'm going to double distribute it, so you get x squared plus 6x plus 9 equals 18x minus 11. Bring those over, you get x squared minus 12x plus 20 equals 0. And the factoring here is not too bad. It's x minus 2, x minus 10. They multiply to negative 2, or add up, multiply to positive 20, add up to negative 12. So I get x equals 2 and x equals 10. Check your answers. You have to. You don't have a choice. So what were my answers? 2 and 10, right? So 2, control var x. Check everything. If you don't know if you have to check it, check everything. X plus 3 is my base. 18x minus 11. Yes, it equals 2. Now I want to change. I want to do negative 10 stow x. Enter. And then just type this in, or just retype it in. Did I hit negative 10 or 10? Oh, I put negative 10, but my answer was 10. So 10. It wasn't negative 10, it was 10 stow x. Ooh, I almost checked it wrong. By the way, if it turns out that it's not going to work, you'll get something like that error, non-real calculation. But if it works, there it is too. Okay, so both those work. I knew they were. That's what bothered me a little bit. How did I know? Because I'm smart. So, woo, this one looks tough. It's really not that bad. Just don't get crazy about it. It's a lot of stuff. They like to screw. That's what logarithms do. They like to mess with your brain. Like, ooh, this is going to be a really tough question. Oh my God, it's so difficult. Okay, look. It's all about the base. So we're going to look here. This is the base. And then these two things are going to switch. So this becomes the exponent. So then it really isn't that hard of a problem, I don't think. You got x plus 2 squared is equal to x cubed plus 13x squared plus 34x plus 9 over x. Well, this side is really x squared plus 4x plus 4 is equal to, I'm going to put this over 1, and now you see it, don't you? You're just going to end up cross multiplying. And this one I get x cubed plus 13x squared plus 34x plus 9 all over x. So I'm going to cross multiply. Go to blue. So these get multiplied. Now don't forget you got to distribute. So you're going to get x cubed plus 4x squared plus 4x. And then 1 times that, that's not a problem. X cubed plus 13x squared plus 34x plus 9. Now we're going to bring things to one side. Well, if I do that, these are going to cancel because you'll just subtract. And so I want to make sure my x squared is positive, so everything's going to go to this side. So I'm going to subtract 4x squared, and I'm going to subtract 4x. So I get 0 is equal to 9x squared, because that's 13 minus 4x squared, plus 30x plus 9. I can take out a 3, which is nice. And I'm left with 3x squared plus 10x plus 3. Factoring is not too difficult here. It's 3x plus 1, 3x plus, not 3x, x plus 3. So I get two answers. I get x equals 1/3. and x equals -3. So, I'm going to tell you right now that if you were to check this, because I don't really want to take all the time in the world, if you were to check this, this -3 would not work. So my answer is 1/3. Moving on. Moving on up. Oh my goodness gracious me. Now this would be more like a typical part 6 question. You look at it and you go, what the heck is that? You are not allowed to solve a logarithmic equation, which we're eventually going to turn into an exponential, but you're not allowed to solve it until you condense this mess. You can't have two logs. Now you have to remember that when you have a minus and you condense, that turns into division. So this becomes log. Now please write your base way down here. Don't make it look like it's part of the problem. These two things divided. 4x cubed minus 18x plus 15 all over 4x equals 2. So that's the first step. You had to condense it. Otherwise, you can't do the problem. Now, it's all about that base, So we're going to write that base down, x plus 2 squared, because these two things switch sides, is equal to, and you can see it now, right? We're going to end up cross multiplying again, 4x cubed minus 18x plus 15 all over 4x. All right. So in order to condense time, I'm going to write this out as x squared plus 4x plus 4. And then I'm going to cross multiply. Excuse me. So I get interesting. So I'm going to get, oh, no, never mind. 4x cubed. I was just about to make a mistake. I knew something was wrong. Plus, remember I'm distributing here, plus 16x squared plus 16x is equal to 4x cubed minus 18x plus 15. Because remember, this is over 1, so I just cross multiplied. So the cool thing is the x cubes cancel, because when I subtract them, I bring them over. And I want to have my squared positive, so there it is, 16x squared. Now when I bring this over, I'm going to add it over, so I get plus 34x minus 15 is equal to 0. Factoring is not easy on this one, not at all. Let's see. Can we start with, I'm going to start with 8x and 2x. I'm not really sure, but yeah, this is it. So this is going to be plus 5 and minus 3, because this makes minus 6 and this makes positive 40. All right, it would have you come on playing around, doing a little bit of work. So I get x equals 3/8 and x equals negative 5 over 2. And once again, I will let you know that you have to check this. And in this case, this negative 5 over 2. It's not always the negatives that cancel, but in this case, the negative 5 over 2 would not work. All right, what do we got next? Hopefully that's it of those. Oh my goodness, it never ends. Oh my God, what is that? I'm going back to factoring over here. Weird. All right, so here's another one. Oh, I know why I put this one in here. Here's the next case. So I have to condense these two, but this time I have addition. Now, when you condense with addition, remember, that really turns into multiplication. So this is log, make sure this base looks like it's down here, x plus 6 of 2 minus 3x times 4 plus x equals 2. Now, it's all about that base, so we're going to do x plus 6 squared is equal to 2 minus 3x times 4 plus x. All right. This becomes x squared plus 12x plus 36 is equal to, now this weird stuff is backwards, so let's do this. 8 plus 2x minus 12x minus 3x squared. Now this is just a minus 10x because I'm going to end up bringing that over. So I get, when I add that 3x squared over here, I get 4x squared. When I add that 10x over, I get plus 22x. And when I subtract that 8, I get plus 28 is equal to 0. I'm going to take out a 2. That leaves me 2x squared plus 11x plus 14 is equal to 0. This looks bothersome. How am I going to get 11 when I have a 14? That doesn't look right. I think I got it now. 2x plus 7x plus 2. Good. So this gives me x equals negative 7 over 2, and this one gives me x equals negative 2. I actually think both of these work. Let me see. Yeah, both of these work. So we'll just leave both those there. Both those work. And I would check them, but time's not in my favor. Why did I put this one back in here? Oh my gosh. All right. Another problem to work on. If you don't want to do it, you've already done a bunch of these, go ahead and skip it. This one I decided to put in because it's got 2 divisions, but you think I would have put it in with the other factoring stuff. That would have been smart. This first one's just going to factor. It's the difference of perfect squares. It's 5y plus 3 and 5y minus 3. This next one I can take out an 8y. So I'm going to take out an 8y and I'm left with 5y plus 3. This one's getting flipped. Don't forget, we're flipping this one. Now 18, 9, and 20. Can't take anything out. Oh, and this is missing a y here, clearly. Let's see. You know what? Not too certain about that one. I'm going to come back to it. This first one, this one has to be 5y and 3y. And when I see this 5y and a 3, so I'm going to put a 3 here and a 4 here. Let's make this positive, and let's make this minus. Would that work? 20 minus 6, 20 minus 9 would be 11. Perfect. All right, so now I'm going to see I got a 3y and a 4, so I'm going to think this is 6y and 3y and probably a 4 and probably a 5. 15, let's see, 24 minus 15, let's go. That's right. So this is plus and this is minus because that'd be 24 minus 15, so that's right. This one's also getting flipped. So I'm taking out a 10y squared and I'm left with 4 minus y. That's the -1 rule. There it is. This one is probably 3y and 2y. 5 and 4. 15 and... Nope. Did you see this 6y right here? I should have known. I should have known this wasn't going to be this. So my guess now is it's going to be 6y and 5 and y and 4, and I need a -29, so these both have to be negative. So -24 and -5 make -29. Okay, good. So now I start lopping crap off. I'm going to take care of my -1 rule first. It's right here. 4 minus y and y minus 4, that's -1. It's backwards, so it's my -1 rule. Don't forget about it. 3y plus 4, 3y plus 4. 5y minus 3, 5y minus 3, 5y plus 3, 5y plus 3, 6y minus 5, 6y minus 5. Holy crap. All right, let's see. This y cancels with one of these y's. And let's see, 2 goes in here 4 times, and 2 goes in here 5 times. So my final answer is -5y over 4. Holy mackerel. That's a cool question. Hopefully I don't have any more of those. I'm sick of those. Oh my gosh. Seriously? Why did I do this? Sorry, kids. I don't know why I'm doing this. Let me do one more. All right, so this is the difference of perfect squares, but this is the -1 rule. You know it's going to happen, so be aware of it. It's 1 minus 3k and 1 plus 3k. I think I just love these problems. I don't know why. I'm a little psychotic. I mean, I gotta be psychotic to love these problems, don't I? 3k and k, let's see, it's got to be minus 5 and minus 1. And then here, let's see, this is missing a k, I don't know why. So I'm going to take out a 3k cubed, and I'm left with 5 minus k. Oops, another negative 1 rule. I got 2 negative 1 rules, that's weird. Here I'm going to take out a k squared, and I'm left with k minus 2. This actually gets, this is really over 1, right? And this is actually going to get flipped. So this becomes 1 over, and I can take out a 9k, and I'm left with 3k plus 1. All right, let me grab my other color. So k minus 5 and 5 minus k is a negative 1 rule. But 1 minus 3k and 3k minus 1 is also a negative 1 rule. And negative 1 times negative 1 is positive 1. So I can get rid of those. This is 1 plus 3k is canceled with 1 plus 3k. Those just cancel. Let's see. 3 goes into 9 3 times. These k cancels 2 of these, leaves me 1. But this k cancels with this k. So my final answer is 1 over 3 times k minus 2. Man, that was fun. All right, so here's an interesting problem. This is one of those log questions that just really bugs kids. So we're going to take this piece by piece. We're going to look at this piece first. So this becomes, remember, we're going to change it to exponential. So 8 to the 4 thirds is equal to x. In other words, x is equal to, now if you did 8 to the 4 thirds in your calculator, it would pop up a 16. Now I think I said that before, but I don't think you believe me. So just do 8 raised to the 4 divided by 3, and it says 16. This one's a little more complicated. This one, the base is y, and my new exponent is negative 3 over 2 is equal to 27. Now, I haven't addressed problems like this in a little while, I think, so you have to be very careful. In order to solve these, you have to raise both sides to the reciprocal, so negative 2 over 3. Negative 2 over 3. Now, go to your calculator. You're going to do 27 raised to the negative 2 divided by 3. Oops, divided by, I don't know what just happened there. So, exponent, negative 2 divided by, that's what I did, 3. And you get 1/9. Remember, negative exponents have nothing to do with being negative. It has to be making into a fraction. So I get y equals 1/9. You've done all the hard part. Now the rest of it's really easy. And the hard part was just using your calculator. I want to know what x divided by y is. Or what is 16 divided by 1/9? Well, I can do it in my calculator and just do it in my head, but control division, 16 divided by control division 1 over 9. By the way, that's the same as 16 times 9 or 144. So the answer is just 144. So it really wasn't that complicated, but boy, I tell you what, you look at that wording and it looks bad. Take each piece individually. Is there something you can do individually to try that one? I think I got a couple more. I think I got one more of these. Oh no, we're going right into binomial probability, so I can't have this highlighted as much. So we'll go page width. Nope, not that much. 125, that's probably pretty good. Okay, sorry, I only had one of those. Thought I had more. I'll try to see if I can come up with some more of those. How many problems do I have left? Oh my gosh, guys, are you guys tired of this? All right, so let's get through these. These are really great questions. They're so easy. Binomial probability. Okay, so you're going to want a highlighter. So junior class is planning a 2-day trip, 60% chance of rain for the next 4 days. Okay, I think I changed the problem but forgot to change this to a 4, so I'm going to do that. So n equals 4 because we have 4 days. R is at least one of the 4 days. Whoa, 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 whoa. So that's at least one of the 4 days. That means 1 or 2 or 3 or 4. So that means all of those days. So find the probability that it would rain on one of those. So it's one, at least one is 1 or 2 or 3 or 4. So P is the probability it will rain. That's 0.6. And Q is the probability it won't rain, which is 0.4. And I didn't really leave enough room for this one, so I'm going to have to remember to go back and change this. So it's not a problem. What we're going to do is we're going to 4C1, that's the first possibility. 4C2, that's the second possibility. 4C3, that's the third. And 4C4. I'll jam it in here. Hopefully when you guys download or print this that you won't have this much of a mess. Now, whatever this exponent is, whatever this thing is right here, that goes here. And they have to add up to 4, 1 and 3. This one would be 2 and 2. This would be 3 and 1. And this would be 4 and 0. In the first one goes P, the probability of what you want to happen. In this case, I want rain, 0.6, 0.6, 0.6, 0.6. For those of you not knowing where I got these from, they have to add up to 1. They add up to 1. So 0.4, 0.4, 0.4, and 0.4. Now the good news is part 2 will be much easier than this. So I'll type this in my calculator, 4C1. So menu 53, 4, 1, 0.6 to the 1, parentheses, 0.4 to the 3. 0.1536. 0.1536. And I think that is exact. So the next one we're just going to change the exponents. So now I want this to be a 2. I want this to be a 2. And I want this to be a 2. This should be a little bit higher. 0.3456. 0.3456. 2 more times. Sorry about that. We're going to change this to a 3. We're going to change this to a 1. And we're going to change... No. This goes to a 3. This goes to a 3. And this one goes to a 1. Sorry, little brain cramp. This one should be even higher. Oh, no, it's going to be this. Why is that the same thing, I wonder? Oh, I know why. So 0.3456. 0.3456. By the way, if you ever add these up and they add to more than 1, start over. You did something stupid. And let's go. Now, this one I can either make a 0 or just get rid of it because it's really just a 1 because anything raised to the 0 power is 1. But you can leave it there if you want. Makes you feel better. Change that to a 4. This changes to a 4. And I get 1296. 0.1296. So I'm going to add all those up. I'm going to hit plus. That's the 1296. This plus. Then I'll hit this one. Plus this one. And I hit enter and I get 0.9744. So 0.9744. I believe that was the answer. Perfect. So then it says find the probability it will rain on at least 2 of these days. Well, 2 of these days, if I was doing this, wouldn't this be n equals 4, r equals at least 2 of these days? So wouldn't that be, that means 2 or 3 or 4. In this case, wouldn't just mean 1. P is still equal to 0.6 and Q is equal to 0.4. Well, 2 out of the 3, wouldn't it just be these? Or wouldn't it just be this answer without the 0.1536? So I just got to really just subtract that 0.1536 Hit enter, 8208. So 0.8208. I was just cheating on that one. So I meant to make this one a little bit bigger in the top and bottom one a little bit smaller. So 5 marbles in a jar, 4 red. So I think I have some correcting to do on this one. When you get it, hopefully it's fixed. And 1 is white. All right, so 5 marbles in a jar, 4 red, 1 is white. So 4 marbles are selected. So N equals 4. R equals at most 2 red. So that's 0 red, 1 red, or 2 red. The probability of getting red is 4 out of 5. The probability of not getting red, which is the same as getting white, is 1 out of 5. So I need 3 equations, 4C0, 4C1, and 4C2, because that's at most 2. Remember, you want to highlight this stuff. Grab your highlighter, say at most 2. So, boom, 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 point, or 4/5, 4/5, 4/5. Now, if this comes out to be a fraction on your calculator, then leave it as a fraction on your calculator. Don't try to convert it to a decimal. This would be 1/5, this would be 1/5, and this would be 1/5. So let's see. Whatever this base is here, whatever this number is here, goes here. So it's 0 and 4, 1 and 3, and 2 and 2. So come over to our calculator. We're going to do menu 3. Oops. Escape. Menu 5, 3. And it's 4, comma 0, parentheses, control division. What is it? 4/5 to the 0, which I really don't need, but I'm going to need it later. So I'll put 4/5 to the 0, parentheses. Why? Because anything raised to the 0 power is just 1. 1 over 5 to the 4th power. Oops, let me get out. And then raised to the 4th power. And I hit enter, and I get 1/625. And it's a fraction, so I'm going to leave it as that. 6 over 25. Over 1 over 625. So then I'm going to do 1. So this gets changed to a 3. Oops. And this gets changed to a 1. Don't forget to change everything, otherwise you're going to have the wrong numbers. Can you guys do me a favor and do every problem twice? Please, 16 over 625. It's so easy just to write 16 over 625 and maybe forget off the 5. And then go add later and do something stupid. And we're almost done. Get this, change this to a 2. Change this to a 2. And change this to a 2. And 96 over 625. 96 over 625. Well, that looks like, let's see, 104, 105, but let's just check it. So we're going to do this plus this plus this. 113. 113 over 625. See? I don't know what I was thinking. Adding some bad stuff in my mouth, in my head. All right. Find the probability that at least 3 red marbles are selected. So that would be N equals 4, R equals 3 or 4, and again, P equals 4/5, Q equals 1/5. So 4C3, my computer is dying on me. 4 out of 5 cubed, 1 out of 5 to the first. 4, I'm going to try to be slow. 4C4, 4/5, 4, 1/5, 0. Go over to my calculator. The good news is can still use this formula. This time it's going to be 1, 1, 3, and 3. 256, 625. 256, 625. Do one more time. Raise this one to the 0. This one to the 4. And change this to a 4. 256, 625. 256, 625. And if you add those, you get 512 out of 625. All right. No. Only red and black cards are in a box. The probability of getting a black card is 2/3. A card is randomly drawn and replaced in the box after each draw. 5 such draws are made. So we're making 5 draws. So n is 5. Find the probability that exactly. Now, whenever you see the word exactly, that means you're only going to have one equation, which is nice. So n equals 5, because we're making 5 draws. R exactly 2, so 2. And we want black cards, so we're going to make sure. So we're going to go P equals 2/3. And if P is 2/3, then Q is 1/3, because don't forget these have to add up to 1. These two things. So it's 5C2, 2/3, 2, 1/3 cube. Because don't forget, these also have to add up to 5. All right, we'll just do that real quick in the old Taschenrechner. That means calculator for those of you that speak a little German. Ein bisschen Deutsch geredet mit dir. Ist das okay? So, 5,2. And then we'll go parentheses. Yes, ich kann ein bisschen Deutsch reden. Yes, I can speak a little German. For my German friends, don't make fun of my German. It's not the best, I know. 2/3. Now we're going to put this exponent's going to be 2. And then 1/3. I'll just do it like this. It'll fix it. And we're going to raise that to the 3rd. And I hit enter. 40 over 243. 40 over 243. Boom. Enough. So now I want at least 4 black cards. Well, if n is 5, at least 4 means r equals 4 or 5. So anytime you have an at least or an at most, you're going to be doing multiple equations. P equals 2/3, Q equals 1/3. So we have 2 equations this time. We've got 5C4 or 5C5. And we'll end up adding those together. It's 2/3 to the 4th and 5th, and then 1/3 to the 1. Don't forget, those have to add up to 5, and this is already a 5, so this is 1/3 to the 0. I hope I don't have too many more problems, because this computer is dying. Meine Computer ist fast tot. My computer is almost dead. 5,4 parentheses, parentheses. Every time somebody doesn't listen to me in my math class, I start speaking in German, because I figured, well, what the heck? Maybe they understand German better. Could I have used the last equation? I should have. I don't know why I didn't. Raise to the 4th. And then I do control. Oops. Parentheses. Delete. 4. Get out of this. Parentheses. Control division. 1/3 raised to the 1st power. That is the 1st power. I could put raised to the 1st. I could just not. It'll take it away. Oh, I thought it would take it away. 80 over 423. 80 over 243. Got a little dyslexic there. And then I hit this one. I'll do the same thing. Enter. Change this to a 0. Change this to a 5. And change this to a 5. 32 over 243. 32 over 243. So my final answer is, you just go over to your calculator, you go plus, that's the 32. 112 over 243. 112 over 243. How many of these problems are left? 1, 2, 3. Yay! 3 more problems. Because Mo, that's Mo Williams, Mo Money. His backyards gets very little sunlight. The probability that a germanium, this thing, will flower is 0.23. Sam planted 5 geraniums. Find the probability to the nearest thousandth that at least 4 will flower. At least, at most, at least or at most, you're going to have to do multiple equations. Est-tu me salade? Excuse me very much. So I want at least 4. That's 4 or 5. My German friends are probably saying, why is that guy trying to speak German? He sounds like a nincompoop. Now, Q is hard. So remember, these have to add up to 1. So if I take 1 and I subtract off 0.23, I get 0.77. So that's the probability that it will not flower. Ooh, this is going to be a low amount. So I hope this works. 5C4, I just made up this problem a little while ago. I took an old Regents and kind of made it. 0.23 to the 4th, 0.77 to the 1th, and then 5C5, 0.23 to the 5, 0.77 to the 0th. That's a word. So, menu 5, 3, 5, comma 4, parentheses, 0.23 raised to the, got to get out of the parentheses, raised to the 4th, parentheses, 0.77 raised to the 1st, 0.01077, 0.01077. I shouldn't round early. Let me get a couple more on there. 387. That should be enough. 387. And then this one is going to be even worse. I don't even know if this is going to work out. Guys, I'm serious. I'm not even going to lie. This made it. As long as you can set these up, we're good. Let's go. We're going 0 here. We're going 0.23 to the 5th. So we got to change that to a 5. And we got to come over here and change this to a 5. This is getting tedious. You got it. If you got it, go on. Oh, that E, that's times 10 to the, so that's 0.0006. So 0.0006, because that's 10 to the minus 4. 4363. 4363. I'm just going to take that thing and I'm going to add to it this. Hopefully I get a nice answer. 0.0114. So 0.0114 175. 175. So if I round this to the nearest thousandths place, that's this. The 4 doesn't round it, so my answer is 0.011. So it's like a 1.1% chance. 2 questions left. Yay! Hopefully it's an exact. Oh, it's not. Whenever Sarah, I have a few Sarahs, like Sarah Wilmot. You going to get 100, Sarah? I hope so. I hope your brother does as well. So how many movies are we renting? 5 movie rentals. We want at least 3. So N equals 5. I want at least 3. So R is 3 or 4 or 5. That's 3 equations. You got to be loving that. She's going to rent a horror movie. P is for a horror movie. 0.72. Q is 0.28. Remember, these have to add up to 1. So 5C3, 5C4, 5C5. The probability of a horror movie, 0.72 to the 3. 0.72 to to the 4, 0.72 to the 5. And then the other one is going to go 0.28. They have to add up to 5, 0. They have to add up to 5, 1. And they have to add up to 5, 2. Getting close, kids. I know it's getting tedious. So menu 5, 3, and it just so happens 5, 3, parentheses, 0.72 raised to the 3rd, parentheses, 0.28 squared. 29, 26, 26. 0.29, 26, 26. Says hundreds. That's going to be good enough. Let's go. Let's go. Let's go. We're having fun. Not. Is this video ever going to end? I feel like I've been recording like for a month. And you guys probably have been listening for a month. Although probably you're fast forwarding. Change that to a 2. Change that to... I'm screwing this up. This should be a 4. Because the next one is 4. And this one should be a 4. So delete and make that a 4. And we get 3762.3762. I need more. More. I need more. 3. Good enough. And this final one, oh my gosh. This goes to a 0. And this goes to a 5. And this one goes to a 5. Hit enter. 1934.91. 1934.91. So now I'm going to add all those up. Have a lot of fun. So plus this, plus this. 8623.862352. Is that what that was? I think it was 52. And round to the nearest hundredth. That's these. That 2's not going to round it, so my answer is 0.86. It's like an 86% chance she's going to get 3 or 4 or 5. Last problem. Ooh, I love this exactly. So let me get my highlighter out. Multiple choice. Oh, and you know there's 8 questions. Each question has 5 choices on the multiple choice. Find the probability of the nearest thousandths that Justin, we're talking about my gooey friend, the gooey man, the Goo-meister. You know who I'm talking about. N equals, we're just going to randomly guess because to heck with it, man. Let's do it. N equals 8. R equals 3. I want to get 3 right. Now, the probability, if there's 5 choices, the probability of getting it right is 1/5. Therefore, the probability of getting it wrong is 4/5. So my equation is going to be 8C3, 1/5 to the cube. And don't forget, these have to add up to 8. 4/5 to the 5th. Luckily for us, we just have to do 1. So we're going to do menu 5, 3, 8, comma 3, parentheses, control division 1 over 5 cubed, control division 4. This is the last problem. It's so exciting. Oh my God, I'm so excited. Forgot what I had to put here. 5 to the 5th power. So hopefully this is a nice fraction. Oh my gosh. 57,344. 57,344 over. This is one of those ones you just have no idea if you got it right. 390,625. 390,625. But it's said to the nearest thousandth. So this is not good enough. I actually have to figure out what this is as a decimal because it does say to the nearest thousandth. So 0.1468. So 0.1468, and then next one was a 0. So rounded to hundreds, then thousands. So there's the thousands. So my answer is 0.147. It's like a 14.7 chance you'll get 3 right. Last problem. No more than 2. So that's n equals 8 r equals 0, 1, or 2, because no more than 2 means you can get 2. P is still 1/5, because there's still a 1/5 chance, and Q is 4/5. All right, we're almost done. 8C0, 8C1, 8C2 equals 1/5, 1/5, 1/5. This is 0, 1, or 2. 4/5, 4/5, and 4/5. Now don't forget, these have to add up to 8. So this is going to be an 8, this is going to be a 7, and this is going to be a 6. Now it doesn't matter if your intermediate values have fractions. It matters that your final answer has to be a decimal. So let's see. Our first one is 0 and 8. 0, there's 8. None right. 0 right. $65, 536. So 65, 536 all over 390,625. Now we're going to do the next one. I know this sounds obnoxious, but it's not bad, kids. You just do it. You just get these numbers in. You got to add up to 8, so ding, 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 1. I hope you guys are studying. Study. If you're at this last problem, you're like that freaky great kid that's awesome, that's going to get 100 on the test. 131,072. 131,072 all over this obnoxious denominator. And finally, I know this is going to be 390,625. I just don't know what the numerator is going to be. Enter. Change this to a 6. Change this to a 2. And change this to a 2. 114,688. 114,688. And I'm going to add all those up. And so I get plus this, plus this. And I'm going to convert that to a decimal because I don't want to write that. That's way too much work. 0.7969. 0.77969. And that's enough to round and just in time. Round to the thousands place, right? So my answer is 0.797. There's a 79.7% chance you'll get no more than 2 correct. All right, that's it, kids. There we go. Man, that was a lot. Hopefully you made it to the end. Hopefully these problems are helping you out. Hopefully this makes a lot of sense. Hopefully I didn't make too many mistakes. Hit the like button. Hit the subscribe button. Send me an email. Tell me how much you love my videos. You don't have to. Just kick butt on the readings. That's all I want. Just kick butt on the readings. See you guys.